All right, guys. So this video, I'm just going to go over the practice quiz that I gave you today, the one for Beer's Law. So your L-1 practice quiz. So it's labeled L-1 and also 2-3 because it's stoichiometry. It's always stoichiometry. And I guess you could also call it making a standardized solution too, because a question like that comes up. So it's really just like, do you understand what we did in the Beers Law Lab, and can you do stoichiometry and stuff like that? So what I want us to do, this video, so the key's posted. You have the key. We're going to go over it in class, but I also wanted to make a video just to kind of make sure in case you missed the class or you're not paying attention or you don't get it when we do it in class or you don't get it just by looking at the key. I'm just going to go through the quiz and just kind of explain some things. Hopefully the video helps you. All right. So in class we went over Beer's Law and kind of the colorimetry lab, the percent brass, copper and brass lab. And you also got a copy of this practice quiz. So practice lab quiz 2-3 and L-1. So the main thing about this L-1, that's the Beer's Law stuff, light being absorbed by different ions and that kind of thing. And the amount of light absorbed is directly proportional with the concentrations of the ions and that kind of thing. So anyway, you're going to have a lab quiz that's very similar to this question. And the reason I'm making a quiz very similar to this question is because this exact question, this was question number 3 on the 2021 free response. And basically it has a bunch of unit 2 stuff covered in this question. And, it's all basically our unit 2 stuff. So stoichiometry, net ionic equations, molarity calculation, and then Beer's Law, spectrophotometry, which is, what we're going to call colorimetry, that kind of thing. So this question has it all. And so I like this question. So this question is our practice quiz, and the quiz you're actually going to take is going to be very similar to this. So hopefully if you understand this, you'll be in good shape. Now, another thing I want to make a note of is when they made the curriculum change in 2013, you no longer had to, they said you no longer had to memorize solubility rules. So most of the time, like when they tell you something precipitates, they'll tell you what the precipitate is. But what I want you to note here is they don't tell you what the precipitate is in this. They tell you that copper sulfate solutions and barium nitrate solutions are mixed in a precipitate forms, but they don't tell us what the precipitate is. Okay? And the only kind of way, the clue that that it's barium sulfate that precipitates and not copper nitrate is copper nitrate is blue. The compound is blue and copper ions are blue in solution, but the compound itself is blue. And same with copper sulfate. Copper sulfate is blue. Copper nitrate is blue. So if you're thinking a double replacement reaction here between copper sulfate and barium nitrate, the two products are barium and sulfate and copper and nitrate. And copper nitrate is a blue solid. So if they said a blue solid formed here, I guess they would be telling you that copper nitrate precipitated out. And the fact that they told you that it's a white solid, and I guess they want you to know that copper nitrate is a blue, makes blue crystals, then if it's not a blue precipitate, then it must be barium sulfate that's the precipitate. So again, that's why I stress that you have the solubility rules. You don't necessarily have to have them memorized, but you should know the most common precipitates that show up on the AP exam. And the most common precipitates are silver with a halogen, so like silver fluoride, silver chloride, silver bromide, lead with a halogen, so maybe lead chloride, lead bromide, that kind of thing, or A very specific one that shows up a lot, and here it is showing up on the AP exam, is barium sulfate. Barium sulfate is a common precipitate that shows up over and over again, year after year, on the AP exam, going all the way back to like 72, right? 1972, if you can think that something could be that old, right? But understand, you know, back in the day, I made all my students memorize the solubility rules because they had to. And so barium sulfate, they'd know right away. Now, since I don't really test you on the solubility rules, I just kind of want you to be familiar with them. Well, hopefully you know that nitrate's always soluble, so it's not going to be copper nitrate. So that means the precipitate's got to be barium sulfate. Hopefully you can make that connection, and hopefully that makes sense to you. All right. So, all right. So here's the deal. The student has a copper sulfate solution. They don't know its molarity. And they're tasked with figuring out the concentration of the copper sulfate solution. So they want to know what the molarity is. And since the subscript of copper is 1 here, whatever the molarity of copper ions is, that's going to be the molarity of the copper sulfate. Okay, great. And so the whole premise of this question is the student does 2 different ways to figure out the molarity of the copper sulfate, right? So the first way is they precipitate all of the sulfate. So they add barium nitrate to the copper sulfate solution, right? These are both aqueous solutions. And so barium sulfate is very insoluble. And so all of the sulfate will precipitate with barium. And so as long as you add an excess amount of barium, you know that all the sulfate will precipitate. And then if you can figure out how much sulfate was in that much barium sulfate, then you could figure out how much sulfate you started with in this solution, so then you could figure out the molarity. All right, so that's the first thing they do, and so that's all set up here. The second thing they do is kind of like what we did to figure out the copper concentration in a brass solution, and so they're going to use, they say spectrophotometry here, but you know what you could also call it colorimetry. And so they're going to see how much light this solution absorbs, how much orange light it absorbs, because copper is blue in solution. All right. So they're going to use Beer's law to figure it out, and they're going to use precipitation to figure it out. All right. So the first thing is that they've done precipitation. All right. So the first thing is just to come up with a net ionic equation for the precipitation reaction, and you know, don't sit there and waste your time writing the complete ionic and then the net ionic and stuff like that. If it's just a precipitation reaction, write the formula of the precipitate on the right side of the equation, and then on the left side of the equation, write the ions that make up that ionic compound. So write the ionic compound as is here, and then write the 2 ions that make up that compound over here. Now, if barium had a subscript, then that subscript for barium in the formula would become its coefficient. So like if it was Ba2 for some reason, then you would have 2 barium ions over here. But that's a very easy way to come up with a net ionic equation if all you have is 2 ionic compounds, solutions, and they're causing a precipitate, right? If there's an acid involved, then it can get complicated because then you got to know whether it's strong or weak or that kind of thing. But right now, if it's just, hey, I got 2 aqueous ionic compound solutions, I get a precipitate, and you want the net ionic equation, you just write the formula of the precipitate, and then the ions that make up the precipitate. That's it. And notice they didn't say include states of matter, so don't include states of matter if they don't say include states of matter, but the ions would be aqueous, and then this would be a solid if you needed it, all right? So calculate the number of moles of precipitate formed. So here, they didn't give us the molar mass of barium sulfate. So what we had to do was first do the mass of the filter paper in the precipitate minus the mass of the filter paper. So that gives us just the mass of the precipitate. And then that mass divided by the molar mass. So we actually had to calculate the molar mass of barium sulfate. But understand, this is question 3 on the AP exam. And the first 3 questions are longer form questions. So the average student usually spends about 20 minutes on this question. So, you know, if this same question would have been asked question 4, question 5, question 6, or question 7 on the AP exam, then they'd probably give you the molar mass, so you wouldn't have to waste time calculating it. all right? But, you have one barium, one sulfur, four oxygens, you calculate your molar mass. So the mass of the precipitate divided by the molar mass gives you how many moles. So that's how many moles of barium sulfate you had. And now you're just calculating the molarity of the original copper sulfate solution. So it's a 1-to-1 ratio. So the moles of barium sulfate equals the moles of copper sulfate you had, because there's 1 mole of sulfate for every 1 mole of barium sulfate, and there was 1 mole of copper sulfate for every 1 mole of sulfate. And then to get the molarity, we take moles of copper sulfate and divide by the volume of the solution that was tested, and the volume of the solution that was tested was 50 milliliters. So divided by 0.05 liters, and you get your molarity. So the units would be moles per liter, or capital M, or moles to the -1, all right? Okay, so that was the student's first way to determine the molarity of the copper sulfate solution, all right? All right, then, now they're going to use Beer's law. But remember, the first thing we did in our brass lab was we made standardized solutions of copper ions so we can make that graph of absorbance versus concentration for copper. So that's what they're doing. So the student uses a 0.1 molar solution of copper sulfate to make 3 more solutions. So they take a 0.1 molar solution and they dilute it to 0.05, 0.03, and 0.01. And notice they give you the volume of your volumetric flask. So remember, that volume is always the final volume of the solution you're trying to make. So if you're doing M1V1 equals M2V2, this is V2, right? Right? So in question D, they're just like, calculate the volume of the 0.1 molar solution they need to make 50 milliliters of a 0.05 molar solution. So they're asking you, how do you dilute this solution, the 0.1 molar solution, to this molarity if the final volume is going to be 50 milliliters? So remember, we did this lab, right? I made a 1 molar solution of copper ions for our brass lab, a 1 molar solution of copper ions, and I gave you a molarity to dilute it to. Now, in our lab, we used 100 mil volumetric flask. In this lab, they're doing 50 milliliters, right? So we're going to do M1V1 equals M2V2, but we're solving for V1. We're solving for the volume of the stock solution we need to dilute to that molarity, knowing that our final volume is 50 milliliters, because that's the volume of our volumetric flask. So we plug in everything, we solve for V1, 25 milliliters. So we're going to need 25 milliliters of this solution, and if we dilute it to that, now the molarity will be that, right? Now, another way to really think about it is you want to half the concentration, 0.1 to 0.05, so that means you need to double the volume, right? So if your final volume is going to be 50, then you got to take 25 milliliters of this, double its volume, and then you get 50, and now you have your new molarity, which is 0.05, right? So in E, all we're doing is describing a procedure to follow to actually make that solution, all right? And using 0.1 molar, 50 milliliter volumetric flask, and other standard laboratory equipment, right? So we need to measure out, right, think about the different kind of things, and don't worry about putting on goggles. They say assume that all appropriate safety precautions will be taken. So it doesn't have to be crazy detail, guys. This is just like, okay, so figure out what you're going to measure your 25 milliliters of your copper sulfate solution, okay? And since they didn't give you a choice between a burette and a graduated cylinder, you could use a graduated cylinder, okay? So you could use a 25 mil graduated cylinder, or maybe you could use a 50 mil burette, but it would be, I'm gonna use a burette because that's more accurate than a 25 milliliter graduated cylinder, but you could use a 25 mil graduated cylinder. So you would rinse the burette with your stock solution. Remember, you always rinse with your solution, not just distill water. Then you're going to load the burette with your stock solution. You're going to dispense 25 milliliters of the solution to your volumetric flask, and then you're going to fill the volumetric flask to the line with distilled water. All right, and there you go. And then, don't write this, but we could write boom baby here because we just made our solution. All right. All right, and then so this is the graph that the student made with its with the absorption versus concentration. So they made their 4 standardized solutions. They measured the absorbance of each of those solutions, and they graphed absorbance versus concentration. Okay, and they give us the absorbance value for our unknown copper sulfate solution, 0.219, and we got to determine the molarity. So we can just use the graph. It's okay just to use the graph. But if we wanted to use Beer's law, remember that's A equals ABC. Remember, lowercase a in that equation is the molar absorptivity, which would be equal to the slope of this line. So if you wanted to, you could calculate the slope of the line, okay? You could calculate the slope of the line, and that would be your lowercase a. Your path length, B, would just be 1, because we're assuming the cuvette didn't change size. And you could solve for C, the concentration, which is measured in molarity here. So you could take your absorbance reading and divide it by the slope of this line, and that would be equal to the concentration. You could do that. You have time to do that, probably measure rise over run. But if you feel like you can estimate it pretty well, then they're going to accept a wide range of answers here, okay? Because they know that you could just go to the absorbance reading, so 2.19, so you're looking for around 2.2, and you're going to go over to where it hits the line, not to where it hits a point, but where it hits the best fit line. And then you're going to go down, and whatever that number is, that's going to be your molarity. So based on this absorbance, I approximated the molarity to be 0.039. Okay. All right. But again, you could use Beer's law if you want to. All right. And then the very last question here is a student performs the same experiment. There are a few drops of water in the cuvette before the student puts their copper solution with unknown concentration in. And we want to know, will this result in the copper concentration of the unknown to be greater than, less than, or equal to the concentration we determined here? Okay? So what are those few drops in the cuvette going to do? They're going to dilute the copper solution that we're adding to the cuvette. So the copper solution is going to be less, okay? So we're going to get a lower absorbance reading because we're not going to have, the concentration is not going to be as concentrated. So if we lower the absorbance reading, we're going to lower our concentration. So the answer would be less than. And if they didn't say justify your answer, just say less than. Don't explain it. But because they said justify your answer, we got to justify. So the answer is less than. The drops of water in the cuvette will dilute the solution and lower the absorbance measurement. This will decrease the molarity, calculated, because absorbance and concentration are directly proportional according to Beer's law. Or you could say it would lower the concentration, and if it lowered lower the absorbance, and if it lowered the absorbance based on the chart, that would lower the measured concentration. Okay? So guys, this is number 3. Now, from an AP exam a couple years ago, notice, and I didn't cut out any of the questions, notice that all the questions that are asked in question number 3 of 2021's AP exam, we've covered all that material so far, okay? So we still have a few more units to go, right? We got 7 units, but there's a lot of knowledge that we are supposed to have accumulated so far, right? This is 10 points out of 46 total points you can get on the free response, okay? So this is not a difficult question, right? If this shows up, if a question like this shows up on your AP exam, like, you should be going, yes, that's 10 free points. Now, yes, you can make some mistakes here and there, but you know what I mean? Like, we should get a lot of points out of a question like this. If we get a question like this on the AP exam, we should get a lot of points, right? So, here's hoping, right? So anyway, I hope that helps you out. The lab quiz will be very similar to this question. So probably measuring the precipitate and then measuring using Beer's law. Um, you know, but if you understood how we did everything there, then you should be perfect for the next quiz that we're gonna do. Okay. All right.